So a little background on myself. Before I was with Nutanix, I was actually a data center architect. I designed data centers for U.S. intelligence agencies and also financial services companies in the U.S. So my background is very much around infrastructure design, data center power design. I also did a lot of data center migration projects with VMware. So as VMware was growing in popularity in the mid-2000s, a lot of data center migration programs. I'm sure a lot of you guys come from that sort of background as well. Now, a little update on Nutanix. We've been selling products. So the company was founded in 2009. We've been selling products since 2011. And in the last 4 years, we've grown to over 750 customers. We have appliances in over 70 countries and 6 continents. And also, in terms of employees, we're over 1,500 employees today. So we've seen a tremendous amount of growth in the last 4 years with this industry and with hyper-convergence. Now, one big recognition for the growth that we've seen is this, which is Gartner, who recently recognized us as a leader in their integrated systems Magic Quadrant. So Nutanix was recognized along with some of these companies who've been around for 20, 25 years plus as the most visionary company for integrated systems. So that was huge recognition for us, and we're very happy with that recognition from Gartner. Another data point on just the hyperconverged market in general. This was a report that was done by IDC that shows the market share, the relative market share of different companies in the hyperconverged space, which is a little bit different than what Gartner classified as integrated systems, because they're including things like VCE and vBlock and FlexPod and those other technologies. So in this specific market share quadrant, you can see that they've identified Nutanix as having 52% plus market share in the industry. So that was great recognition as well. Now, for those of you who aren't familiar, what does Nutanix actually do and what have we done? So I want to go through that quickly, and then I'll get to some of the stuff that we're doing going forward and some of the new technologies that we're working on today. So how Nutanix started, basically we identified one of the biggest issues with virtualization, and one of the things that held back VMware in particular was the complexity of storage and the complexity of deploying and scaling and managing storage, as well as the fiber channel fabric or the networking fabric for that storage. So I remember back to when I was tasked with installing 20, 30, 40 NetApp systems for a federal agency. It took months and months to deploy these systems. All of the systems had to be managed separately. I had to configure each system separately. There wasn't an easy way to scale and grow. And there was also all this complexity with zoning and HBAs and LUN masking. All of this that didn't necessarily have anything to do with the services that I was trying to provide from that storage. So we looked at this sort of legacy architecture where you have your servers, your storage, and your networking fabric, and we said, how can we simplify that architecture? And how can we make the enterprise data center with VMware look a lot more like the data centers of Facebook and Google and Microsoft, where they were not using centralized storage to provide any of the services that they were providing? And what we saw from those data centers, touring some of these data centers back, I've had the opportunity to visit several Google data centers and Microsoft data centers. Like I said, they weren't using centralized storage. They were building Azure and Bing and these services, Google services, Gmail. All of these services were built on commodity x86 hardware. And the intelligence of those services were were built as software on top of that commodity hardware. They did not use any sort of centralized storage. They built their own distributed storage software systems to run these services. And in a lot of cases, for Google, it was GFS. Microsoft has several of their own distributed systems for storage. So we went to thinking, how can we build a distributed storage system that works for enterprise virtualization? And how can you get the same benefits as some of these larger web scale companies have seen with moving storage from a physical centralized hardware entity to a distributed software system that can be run on commodity hardware. So that was the first step of Nutanix, and that's been the journey that we've been going through in the last 4 years. And we've seen a lot of benefits, in terms of lower predictable cost, lower total cost of ownership, simpler, it's much easier to scale. When you have a distributed system, you can simply add nodes if you need more storage. So there are a lot of benefits that we see to moving towards a different architecture for enterprise storage. And at the end of the day, what you get is this very simple building block. So a data center building block. It's a single system. It has the software ready to go, pre-installed. It's easy to deploy. And these systems communicate with each other to form this large resource pool, these storage pools and pools of compute using whatever hypervisor that you want. So we support 3 different hypervisors in this case. We support VMware, obviously, ESX, which is the large majority of our customers today. And we also support Hyper-V and our own version of KVM with our own management software, which is called Acropolis. Okay, so this is one version of a Nutanix appliance. We have a whole different set of Nutanix appliances, ones that are very compute heavy, ones that are very storage heavy, ones that have maybe more memory if you're running in-memory databases. So there are a lot of different options in terms of nodes for Nutanix. And you can actually mix and match different types of nodes within the same cluster. This is just one example of one of the more popular nodes, just so you could get a view of it. And it's actually, so it's a 2U box, and inside of it are 4 servers. And those servers, they don't have any shared there's 2 power backplanes, but other than that, it's a 2U 4-slot sheet metal chassis. Each one of these servers has two sockets, 8, 10, 12 cores, depending on what Intel chipset you're using. It has SSDs, it has HDDs, and it also has dual 10 gig E. So all of these servers connect to each other, not through some backplane on the actual chassis, but through top of rack 10 gig switches. So normally how these are deployed, you'll have, let's just say you're deploying a single cluster. One of these 2U blocks can be an entire cluster because there's 4 nodes. So you connect each node to the 2 top of rack switches, 2 10 gig top of rack switches, and then you run the software. And it has both the compute and the storage that you need to run virtual machines and whatever virtualized workloads that you want to run on the system. We run our software then as a virtual machine on every system in the cluster. So Nutanix software runs on top of whatever hypervisor you choose. And all of that is automatically deployed through a process and through a technology that we have, which is called Foundation. So Foundation can take 4, 10, 100 nodes that are all on the same layer 2 network. You provide it with whatever hypervisor image that you want. So whether it's an ESXi image or a Hyper-V image or a KVM image, it'll layer on that image onto every server node in the system, every Nutanix server node, and then on top of that hypervisor deployment, it will provision a VM that has all of our software on it. And those VMs all communicate with each other to form a distributed system that includes our storage technology and our distributed file system. And that distributed file system has all of the same sort of features and important technologies that have been traditionally associated with centralized storage, like snapshots, like deduplication, like compression, DR, and obviously replication, site-to-site replication, metro availability. All of those features are available even though storage is not some refrigerator sitting on the side or some silo of infrastructure. All of those features are built into the actual software. Now, the other cool thing is we have some new features that couldn't exist with the traditional three-tier architecture. One big example is VM data locality. So with this topology, your VMs can run on the servers where their data is actually stored. So when a VM writes to the flash or the HDDs on the local node, it'll write locally. It'll also write one replica to a different node in the system. Now, when it reads that data is going to be local. It's going to be on local flash. So it doesn't have to, when it's doing reads after a write, it doesn't have to make a hop over the network to a storage controller that sits on the other side of the network in order to read that data. So that's a benefit of hyperconvergence, is that your VMs and your data can sit close together. And there are a lot of benefits for scalability because of that. You dramatically reduce the amount of network traffic because all of the VMs aren't having to go over the network. And that's why we're able to not have to deploy dedicated storage networks. And we can leverage the same 10 gig E fabric that the VMs are leveraging for their own communication. Okay. So, like I said, looking through some of the web scale companies' data centers, you'll see sort of uniformity. You'll see a lot of them are deployed in storage containers, like not IT storage, but shipping storage containers. So you'll see a storage container with shelves and shelves of x86 servers. If you look at these are some of our enterprise customers' data centers, you'll see a very similar look and feel to some of those web scale data centers. It's a bunch of x86 servers tied together with a 10 gig E fabric and top-of-rack switches. So it's a very simple way to build a data center, to build a virtual private cloud. And like I had mentioned before, with the Nutanix technology, it's really easy to scale. If you want more compute or storage capacity, you can simply add nodes to the fabric. They're auto-discovered. If they exist on the same layer 2 network as an existing cluster, they're auto-discovered using a protocol called Avahi, which is the same as it's an open source version of Apple's discovery protocol. So we'll use Avahi to auto-discover nodes on the same layer 2 network. You simply can add them then to the cluster. We'll update them to be in sync with the rest of the nodes in the cluster so that they're running the same software, the same hypervisor. We'll deploy our software on that node, and then it can join the cluster and become a part of that distributed system. And yeah, if there's any questions as we go along, I don't know if we have a mic. Well, I'll have a Q&A later at the end of the session. But if anyone wants to interrupt or ask any questions, that's fine as well. I want to keep it as interactive as possible. All right, so quickly before we get into some of the newer stuff, what solutions does Nutanix target today? So Nutanix is deployed across a variety of use cases. The most common solutions are just general server virtualization. So whether it's 3-tier web applications, databases, SQL, Oracle, Microsoft Exchange, SharePoint, VDI is a very popular use case as well. So anything that can be virtualized or has been virtualized on VMware, we are now running on Nutanix. Now, in terms of industries, we target, we're very big in the federal government, US and also international federal government, financial services, healthcare, SLED, state and local government, education and service providers. So those are the main industries that we've seen a lot of success in. Just to go through this quickly. You know, some other applications, unified communications is a big area of growth for us. So whether it's Cisco UC and Collab, Microsoft Link, or Avaya Aura, and Avaya IP Office, we're seeing a lot of growth in those areas and folks that are choosing to virtualize their UC infrastructure on top of Nutanix. One of the big announcements we actually made recently in terms of solutions and use cases, actually I think it was last month or 2 months ago, we actually announced a partnership with SAP, and we are the first hyper-converged system that's certified to run SAP technology. So we have several SAP NetWeaver customers, and this is a big one for us because SAP is traditionally customers are very conservative with their SAP environments. So to move from VDI, which is a greenfield infrastructure deployment, to heavy databases and Oracle and SQL, to now running SAP, we've kind of been going through that phase of growth and phases of maturity as our technology has matured. So the second major partnership we announced, and this was just a couple weeks back, we have Dell who's OEMing our software as part of the XC line of appliances. With this new announcement, Lenovo has actually has signed an OEM agreement with Nutanix. They will be producing their own line of appliances, Lenovo branded appliances that run Nutanix software. So we're very excited about that partnership. We think it opens up a lot of markets for us, especially in China. I know also Italy is traditionally a big fan of IBM and IBM technology, and so I think there's a lot of opportunity there for us with Lenovo. All right, just a quick customer logo slide. A couple of my favorite ones that I recently visited, Nintendo is a big one. So Nintendo runs a lot of their Oracle infrastructure on Nutanix. So I had the opportunity to go to Seattle and Nintendo of America and check them out. But a lot of customers we're very proud of here. And obviously we have a lot of customer references that can tell you more about their experiences with Nutanix and with our technology. All right, so next section, I wanted to get into a little bit more about what we're doing next. So we talked about storage and how we've simplified enterprise storage. Where are we looking to go? Because we don't consider ourselves as a storage company. We never wanted to be a storage company. We wanted to be a virtual computing company. So I wanted to talk about a couple things that we've been working on and we recently announced at our own user conference that have to do with what's next for us. So we talked about how you make storage invisible as a resource so that there's not this concept of centralized storage in a data center. The next two steps for us is how do we make virtualization easier and simple in the same way that we've done with storage. And some of those things are more difficult for virtualization admin to understand because they're so used to doing them. So I want to talk about a couple areas where we think virtualization is complex and we have opportunities to improve it and simplify it. And then the last step is, how can we make cloud simpler? So there are a lot of customers that are interested in leveraging AWS or Azure or some of the software as a service applications that are out there today. How do we make the transition or a hybrid cloud type deployment easier, and how can we embrace some of those technologies? Now, what all of the sort of features and the new technologies we're developing in each of these areas are under an umbrella that we call Nutanix Acropolis. So that actually includes our hypervisor. Another slide on that. The three key components of Nutanix Acropolis are the hypervisor itself, which is based on KVM, the distributed storage fabric, so that's NDFS and all of the sort of features we already talked about in our primary technology for the past 4 years, and also this new concept of an app mobility fabric. Now, to start out, before we get into the app mobility fabric and also the hypervisor technology, I wanted to talk about a couple things that are new as part of the storage fabric in NDFS. One of the first things is we now have a CTO model. So when you're purchasing nodes from Nutanix, you can actually order more like Dell in terms of what sort of configuration you want. They're not just a set amount of SSDs and RAM and HDDs. You have a lot more choice in terms of what you order and configure. Now, next thing I talked about already, we've added an all-flash platform, which is our NX 9000 series. And we've also added support for you to have hybrid cluster deployments. So different types of nodes in the same deployment. And the file system is intelligent enough to sort of spread data according to what types of nodes are configured in that hybrid deployment. Okay, we've added a feature which allows you to pin specifically hungry VMs to flash. So if there's one or two very intense VMs that you want all of their data to sit in flash, that's simply a checkbox that you can check on the VM. And that'll ensure that that VM's data is only kept in flash, and we won't tier it down to the colder tier of storage. And then also we've announced Erasure Encoding, or we've released Erasure Encoding, which is sort of like the best way to explain it is RAID for a distributed system. So instead of having 2 or 3 replicas, we actually calculate parity, and we store parity bits. So the advantage of something like this is it's less storage utilization for storing the same amount of data. The disadvantage is, as with RAID, when you have any sort of failure, you have to read all of the data to recalculate the parity or discover what's missing so that it can be reproduced or replicated. So it's very similar to RAID in terms of the advantages and disadvantages, but it works across a distributed set of nodes rather than a distributed set of disks. Okay. So the app mobility fabric, this is a big area that we've expanded to, and the reason was we wanted to make it easy for customers to choose between, public cloud, private cloud, and also different hypervisors. So the primary purpose of the app mobility fabric is to abstract the VM from whatever it's running on underneath. In a sense that we can take a VM that's perhaps running on Hyper-V and move it to ESX or move it to Acropolis without having to necessarily modify or recopy all of that data. So it's a fabric that allows us to change the format of the files while maintaining all of the VM's data within our distributed file system. So we showed off some cool demos as part of our .next event, where we actually did transition of not just VMs, but of hosts between different hypervisors. And we also showed off moving a VM from a format on-prem into AMIs and into AWS on EBS. So those are the types of features that we're working on, that we've demoed several of them, that are working their way into our product. We want to make it very easy for customers to choose between different on-prem virtualization solutions, and also between different the couple different major public cloud technologies. Now, the last component of Acropolis, or the last major component of Acropolis, is actually we developed our own hypervisor and hypervisor management solution. So this hypervisor supports, a lot of the common features that you're familiar with in terms of high availability, snapshots, clones, virtual networking, live migration. All of those features are supported by this hypervisor. What's also very cool about and different about this solution is it's not based on like a single management server, single management database topology. The actual metadata and the management solution is built on top of the same distributed system as our file system. So the management fabric itself scales, and you're allowed to scale that out as you add more nodes, the management fabric itself scales. And that's different than any other on-prem management solution that I'm aware of. All of these features and this technology is managed by our interface, which is called Nutanix Prism. So we've added a lot to Nutanix Prism recently. We've added search functionality, simple search. You can also add filters and stuff. It's very similar to the AWS search interface, if anyone's familiar with that. Very easy to use. It works across multiple clusters, and also provides statistics on VM utilization, storage performance, and anything else to do with your storage and compute environment. Now, the other key component for us in all this technology is making it very easy to automate and to build on top of. So there are a lot of folks using things like Salt and Chef and Puppet to automate Nutanix deployments and configurations. We make it really easy with the API that we have. And we have an API Explorer that you can go and look at every call that you can make to the API, as well as the expected input and output to each of those calls. So I've found it really easy to build any sort of automation or any advancement on top of Acropolis or our storage technology. So that's very cool and something that we're really proud of. Okay, the last thing I wanted to mention here about our support team. So I used to run support for the first 2 years of the company. We have an intense focus on customers. So with any new technology, there's obviously a lot of new features, new functionality to deal with. We make sure that we make it simple for customers to get a hold of our support team. So we have a portal. It's very easy to create cases, get in contact with support. Our support is not traditional in the sense that we don't have like many layers of support. So you'll see that the common idea or the common support team in enterprise computing, they generally have these lower tier support engineers, then level 2, then level 3, then escalations engineers. And it takes you a while to get to the person that can solve your issue. So we've kind of done away with that model in our support organization. We only hire and we only have escalation level engineers on staff. So when you call, you're getting an escalation level engineer. And I think that's important because my experience, when I was on the consulting side with a lot of these enterprise support, my interaction and my experience was not very good. So when I built this support organization, that was a main goal of mine, is to change that whole process and change that whole idea. Because the tendency is that the folks that are calling us for support, they are very well ingrained in the technology, and they have a very good idea in terms of what they need. And I'd like to get them in contact with the highest level resources that we have as soon as possible so that we can solve their issues. Okay. And our main support centers, we do follow the sun model. We have support centers in San Jose, Durham, North Carolina, Amsterdam, Bangalore, Tokyo, and Sydney. So that's how our support team is configured. One of the other cool things, we have a 91 Net Promoter Score, which is what they ask a customer after they're done with the support call is, what is the likelihood that you'd recommend Nutanix to your friend? Which is a lot different question than how satisfied are you with how we handled your case? So very different questions. How likely would you be to recommend Nutanix to a friend? It's a lot harder to answer that question in a positive way than it is, how well did you handle my case? So Net Promoter Score is actually based on the answer to that question. And we have a very high score of 91. Now, in terms of the rest of our technology and details, 5 minutes? Okay. In terms of the rest of our technology, we're very transparent in terms of what we use underneath the covers within Nutanix. And all of that information we actually release on the Nutanix Bible. So if you go to nutanixbible.com, you can see more detail than you'd ever want to know about our technology and our product and what we're using underneath the covers to build out these features.